So welcome to EduMaths. Before you can master circle geometry, there are some basics that you must know. The first one here is an angle is formed when two lines meet. That's the first thing you need to know. An angle is formed when two lines meet. So if you have a line like this and you have another line like this law is just saying that an angle is formed when two lines meet. It means that anywhere two lines are touching each other, there's an angle there. So there's an angle at this point here. There's another angle at this point. There's even an angle at the back here. It's called the reflex angle. Okay, anywhere two lines meet, anywhere you have two lines intersecting, there's an angle in between them. And the next thing you need to know is sum of angles on a straight line is 180 degrees. Okay, on this line is 180 degrees. You measure with the protractor. The angle on this line is 180 degrees. Okay, 180 degrees. Even at the back here, it's still 180 degrees. When you have two lines on the straight line meeting, maybe something like this, so right here you have two angles here. Okay, so you have this angle here and this angle here. So these two angles, this one and this one, they are meeting at on this straight line. Both of them are standing on this straight line. You can see from here to here standing on this line, here to here standing on this line. So total of these angles, if you add these two angles together, you must get to 180. Take for example, this angle here can be 50 degrees. So if this place is 50 degrees, then this one here must be something that you add to 150, that will give you 180. So you see 180 minus 50 degrees, that will give you 130 degrees. So these two angles must add up to 180. Why? Because they are standing on this straight line. So let's move to the third one. The third one is sum of angles at a point is equals to 360 degrees. So we have this figure here. We have all these lines meeting at a particular point. The name of that point is center O. So let's count how many angles we have here. You have 1, 2, so there are 6 angles here, and all these 6 angles are meeting at this particular point. Okay. Now, since these angles are meeting at this particular point, the sum of angles at this particular point will be 360 degrees. If you add all these angles together, angle 1 plus angle 2 plus, if you add everything, you must get 360 degrees because all these angles are meeting at the point. So the next one is sum of angles in a triangle is 180 degrees. So this is a triangle here. These three angles here, this, and this. If you add the three of them, you must get 180 degrees. Okay, the sum of angle in a triangle is 180. Take for example, if this place is 100, for example, 100 degrees, and here is 40 degrees. So that means you have 140 degrees already. Total must be 180. So 180 minus 140, here will be 40 degrees. So that the whole thing will be 180. So it's very, very simple, as you can see. Then at times you might have what is called equilateral triangle. Equilateral triangle. This part is equal, this part is equal, this part is equal. So this triangle is called equilateral triangle because all three sides are equal. So if all three sides are equal, that means the total angle is 180 already. So you have 180, you are dividing by 3 because the three angles are equal. So that will give you 60. So that means all the angles of an equilateral triangle is 60 degrees. So everything here is 60, 60, 60, all true. Then there's another one called isosceles triangle. Only two sides are equal, this part and this part. Okay, if two sides are equal, then that means the angle at the bottom part here, this part and this part will be the same. These two angles will be the same. So if here is 40, this place too must be 40. Okay, we have the sum of angles in the quadrilateral is 360 degrees. So you might ask yourself, what's the quadrilateral? So quadrilateral, quad is from the word 4, so it means 4. So lateral means side. So this is a 4-sided figure. Quadrilateral is a 4-sided figure. So any 4-sided shape, as far as that's 4 lines bounding it, this is a quadrilateral. And all the angles inside it, all the angles inside must give you 360 degrees if you add all the angles inside. So don't forget that. For a triangle, it is 180 degrees, but for a quadrilateral, a 4-sided shape, is 360 degrees. Next one, we have vertically opposite angles are equal. So you might ask yourself, what are vertically opposite angles? So these are angles that are facing each other. Take for example, you have this line and you have another line like this. And then if for this case, the angle here that is here, the angle here, and the angle that is here, they are actually equal. They are the same thing because they are facing each other, as you can see. They are facing each other, so they are vertically opposite. If, for example, this place is 30 degrees, for example, here's 30. If you stretch here back like this, if you stretch this line backwards, stretch this part backwards like this, and bring this part downwards like this. This place too will be 30 degrees. So it's just the same idea. For them to face each other, you must stretch one part backwards. This particular one, for example, was originally like this. It was like this before. It was like this. Let me assume here is 20 degrees. So by the time you move this part back like this, move this part backwards and move here backwards, this part will now be 20 degrees. You can see they will not be facing each other. So take note of that. So the next one is alternate angles are equal. Alternate angles are equal. So for you to understand this concept, you must know about what's called transversal. So what's a transversal? It's just a line that cuts through other parallel lines. Take for example, you have this parallel line, you have another parallel line like this. Then there's a line that now cuts through both of them like this. This line is called a transversal. Okay, this one too will be a transversal. As far as cutting through the parallel lines, through the pair of parallel lines, it will be transversal. And this arrow here shows that these two lines are parallel. They are moving in the same direction. You can see this sign here means they are parallel. Now, what are alternate angles? So alternate angles will be in this way. They will be on opposite side of the line. Now, if one of the angles is here, put one here, A, for example, this angle A. Now you come to this other side here, this side here, and put angle A here. These two angles will be the same. So if you can see what's going on here, look at this line here, this line. Angle A is here, and on the other side of this line, at this point here, let me say this point is point P, and this is point Q. So at point P, A is on the upper part, but at the point Q, to be on the lower part. They will be on alternate side of the line. Like if one is here, for example, the other one will be on the other side. But both of them will be within the parallel line. You can see the parallel lines, see the boundary 1, the second boundary 2. A and the other A, they are within the line. Not as if one of them is outside. Both of them are bounded by this line like this. So it's very, very important. Note that they are bounded by this line. They are not going outside the parallel line, and they are on alternate side of the line. So let me try one here. If here is P, for example, this angle P, for example, or let me say if here is angle P, for example, you come to this side here and put P here. You can see P on this side. On the other side of the line will be P, not on the same side, and both of them will be within the parallel line. You can see that P has not gotten out of the line. It's still within the parallel line, guiding here, guiding here. So take note of that. Let me give you an example based on this concept. Now look at this example here. You have to find X, Y, and A. You have to find angle X, angle Y, and angle A. So it's very, very straightforward. Don't forget the laws that we've discussed so far. So the first thing to do, let's find angle Y first. So let's look at Y. You can see angle Y is facing 20 degrees. You can see they're actually facing each other. Look at this line, and this line forming 20 degrees. This line and this line. If you stretch this part backwards and bring this one downwards, you have Y. That's the concept of vertically opposite angles. When you have an angle like this, if here is 40, if you stretch here down and bring here down, this place too will be 40. They'll be facing each other. So automatically you can see that angle Y 20 degrees. Okay, it's facing 20 degrees. Now for X, to find X, don't forget X will be the angle here. Alternate angles are equal. So this is X on this side of the line. It will be equal to the one on this other side here. Okay, because they are on opposite side of the line. This one is here, this one is on the other side, and both of them are within the parallel line. The parallel line is guiding both of them. None of them is outside the line. So let's find the angle that is here first. So let me say that angle is A. Now, let me not use A because there's A here already. Let me say the angle is P. So this angle, if this angle is P, just look at this red line. Look at this red line. As you can see, 20 degrees on this line, like this, 20 degrees. P is also on that same straight line. This line and this line forming angle P. This line and this line forming angle 20. Both of them are standing on this red line. So that means they're on the same straight line. So to get P, you just do 180 minus 20. So P will be 160 degrees. So if P is 160 degrees, P and X will have the same answer because they are alternate angles. They are on other side of this red line, which is the transversal. So you can see that x will be equals to p, and the reason is because they are alternate angles. So the answer for x will be equals to 160 degrees. Okay, and for a here, a is very straightforward. You can see a is alternate to 40 degrees, and both of them are within this line. A is on this side, 40 degrees on the other side. So automatically you can say a is 40 degrees. So that's how to apply these theorems, transversals, and we're talking about corresponding angles now. So corresponding just means the angles are on the same side. It's the opposite of alternate angles. So in this case, the angles are on the same side. But take note of the fact that one of the angles is outside the parallel line and one of them is inside. Okay, so these corresponding angles, let me assume this place is angle A. Now the corresponding angle to this angle A on this other side here, if this part is maybe say x, this point x, this is point y. So at point x you have angle A. The corresponding angle to angle A on point y will be on this same side. You can see on this same line, this underneath this red line. So this place too will be A. So you can see that this angle A, this one is within the parallel lines. Look at the parallel lines. This one is enclosed by this line. It's within it. But what this A is outside it. Okay, so that's the idea for corresponding angles. One of them will be inside, one will be outside, but both of them will be on the same side of the line. This is alternate angle here. If here is A, for example, this other side here will be A, but both of them are within the parallel line. As you can see, they are within. None of one is jumping out. So for corresponding angle, one of them will be inside like this. Let me take it as angle P. As you can see, it's angle P. Then come to this side here. This place will be angle P. Not this side, but this side, and not underneath here. If here is P, this is inside the parallel line. Then outside it here, on the same side of this line, you also have P. So if you are using numbers, for example, if here is 40 degrees, you come to this side and put 40 here, your answer will be correct, because this is corresponding angles. They are on the same side of the line. It's just the same line because they are parallel. This line is parallel to this line. So if you are drawing this line and putting the mark like this on it, it's the same thing as drawing another parallel line and putting the same mark on it. So both of them will have the same angle. So corresponding angles are they are equal and they're on the same side of the line, but one of them is outside while the other one is inside. Okay, so it's very, very important for you to take note of that. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. What does that mean? Now, these marks here, this is a triangle here, ABC. These marks inside the triangle are the interior angles. Why? Because they are inside the triangle. Don't forget, an angle is formed where two lines meet. Okay, so these are the interior angles. They are inside the triangle. Now, the exterior angle are the angles outside. When you stretch here backwards like this, when you stretch here back, the angle that is here is the exterior angle. Okay, so let me stretch here forward like this. If I stretch here forward like this, there will be an angle at this point here, because angles are formed whenever two lines meet. So that means there will be an angle at this point here. Now, this is the exterior angle. This one is exterior, while this one is interior. So with that in mind, the theorem is saying that the angle that is here is equal to the sum of these two angles. If you add these two angles together, if you add them together, you will get the one that is outside here. That's what the theorem is saying. Take for example, if here is 40, if here is 100 for example, and here is 40, you notice a triangle. Angles on a triangle, total angle in a triangle is 180. So this place must give me something that will make it to be 180. So 100 plus 40 is 140. 180 minus 140 will give me 180 minus 140 will give me 40 degrees. That means this place is 40 degrees. But this theorem is saying that the exterior angle, the angle that is here, is equal to the sum of these two, because these two angles are facing this angle. They are facing this part like this. So this angle here, if you add these two interior angles, you must get this outside one. And you can easily prove that this 40 degrees is on the straight line. You can see it's at this point here, it's on a straight line. And angles on a straight line is 180. So if you do 180 minus this 40, you will get 140 degrees. That means this angle that is here is 140 degrees. And also from this theorem, 100 plus 40 is also 140 degrees. So you can either add this 100 plus 40 and get this answer here, or you do angles on a straight line, 180 minus 40, and get 140. So you can see that the theorem is accurate. The sum of angles in a triangle is 180 degrees. Okay, take note of that. And the exterior angle is equal to the sum of the two opposite interior angles. If you want to find the angle that is here, for example, the exterior angle at this point here, you're going to add 40 plus 40 together. So 40 plus 40 will give you 80. So that means the exterior angle here is 80, and so on. Okay, so that's the idea. These are the 9 important concepts that you must know before you can begin circle geometry. So watch this next video on your screen to know about the basics of circle geometry. Thank you for watching.